find DFT of the sequence x of n is equal to a into n. So here a is a constant and n can take the value from 0 to the n is less than or equal to the n minus 1 it will take, and we are going to assume a is the constant. To find the DFT of this sequence, we'll consider the generalized formula we'll consider, that is the DFT of x of n is equal to x of k, that is summation n is equal to 0 to n minus 1 x of n into omega into the power of kn. So here we are going to substitute the formula for the x of n. So it will become x of n is nothing but a into n will substitute. So it has become a into summation n is equal to 0 to n minus 1 n into omega into the power of k to the power of n. So we can write omega into the power of k, n, we can write as a omega into the power of k to the power of n we can write. So now what we'll do is, let us write this as a power of n we'll write and call this as equation number 1 here. So since we don't have any generalized formula in terms of n into a to the power of n, so we have the sum of finite terms formula is there. The sum of finite terms formula is summation n is equal to 0 to n minus 1 b to the power of n. So this is equal to 1 minus b to the power of n divided by 1 minus b, provided b should not be equal to 1. So now to avoid the confusion, instead of a here, we are taken as b here. Now, so we have the formula in terms of b to the power of n, but we don't have any formula in terms of n into b to the power of n. So what we are going to do is, we'll convert this as I call this as equation number 2, and we are going to convert this formula in terms of the n into b to the power of n will do convert here. So for that one, what we'll do is we are going to differentiate on the LHS and the RHS part with respect to the n. We are going to differentiate so that we can convert this formula equation number 2 in terms of the equation number 1. So now to differentiate this one. So this is in terms of the u by v term is there. So the differentiation of u by v is nothing but v into the differentiation of u minus the differentiation will be considered here. So it is considered as the differentiation will be considered here as so it is the differentiation of, so it is u by v. We are going to consider it is nothing but v into the differentiation of u minus u into the differentiation of v. So this whole thing divided by the v square. So we are going to differentiate this one in terms of the u by v formula will do differentiate here. So now what we'll do is, if you're going to different, and also the differentiation of x to the power of n is n into x to the power of n minus 1. Here also x to the power of n is there. So it is n into x to the power of n minus 1 we can take here. Now let us differentiate both the sides with respect to the b will do differentiate here. So the differentiation will be getting like this. The differentiation of b to the power of n is summation n into b to the power of n minus 1, and the denominator 1 minus b will get, and the differentiation of the numerator 1 is it's a 0, and b to the power of n is n into b to the power of n minus 1 minus the denominator, it is the numerator 1 minus b to the power of n, and the differentiation of the denominator, the differentiation of 1 is 0, and the differentiation of b is nothing but 1 will get divided by 1 minus b the whole square. Now we'll simplify the RHS part. In the meantime, b to the power of n minus 1 is there. We can write this one as also as b to the power of n divided by b we can write here. So first let us simplify the RHS part. Let us multiply 1 with all the terms, and let us multiply minus b with all the terms here. So we'll get the required quantity. So 1 into 0, it's a 0. 1 into minus n to the power of b to the power of n minus 1 is, so we'll get minus n into b into n minus 1. And similarly, minus b into minus into minus will become plus. B into n minus 1 will become n minus 1, and b will get cancelled. So we'll get as b to the power of n. And similarly, minus 1 into minus, it will become plus 1. And the minus into minus will become plus into minus is minus b to the power of n will get divided by the denominator will get. So now what we'll do is, on the LHS part, b to the power of n divided by b is there. So this b will cross multiply on this side. So if you cross multiply b here, so it will become, if you multiply b to this one, minus n into b to the power of n minus 1 into b. So it will become minus n into b to the power of n. And again, if you multiply b, so n into b to the power of n plus multiplication of 1 with b is will become b, and b to the power of n into b divided by 1 minus b the whole square. The denominator will remain same. Now we got this LHS part of the equation. Summation n is equal to 0 to n minus 1, n into b to the power of n is it. So this is in terms of the equal to the part of the equation 1, that is n into omega n to the power of kn. So in place of omega n to the power of k, we can substitute b. So let us substitute b is equal to the omega n to the power of k in this equation. So we'll substitute b is equal to omega n to the power of k on the LHS and the RHS part. So wherever b is there, we can replace with the omega n to the power of k, we can do replace. So if you keep substituting here, so it is become n into omega n to the power of k into n minus n, and b to the power of capital N is there, it has omega n to the power of k into n plus n into b, it is omega n to the power of k, and b to the power of capital N is there, it is omega n to the power of k into n, and here b is there, so it's omega n to the power of k minus b to the power of n, omega n to the power of k to the power of n into omega n to the power of k, so divided by 1 minus omega n to the power of k the whole square. So here what we can do is we'll simplify this expression. So we know that omega n to the power of k into n is nothing but 1. We'll do substitute that one. So omega n to the power of k to the power of capital N, which is nothing but 1. Here also it's 1. Here also 1. The remaining thing is minus n into plus n into omega n to the power of k plus omega n to the power of k, and these terms will get. So here we'll get minus n plus n into these terms. So omega n to the power of k and minus omega n to the power of k, both will get cancelled. The remaining quantities, if I take minus n common, it is 1 minus omega n to the power of k divided by 1 minus omega n to the power of k the whole square. So the square and this terms will get cancelled. So the remaining quantity will be summation. The LHS part is n into omega n to the power of k is equal to minus 1 divided by minus omega n to the power of k the whole square. So since minus is there, so let us multiply the minus with the denominator. So omega n to the power of k minus 1 the whole, this square is not there yet. So because already we have cancelled the square here. So because this square and this one has been cancelled, so it is minus 1 divided by 1 minus omega n to the power of k. So here when we multiply minus to the denominator, it is become 1 divided by omega n to the power of k minus 1. And this is for the case if I substitute k is equal to 0, this will become 1. Omega n to the power of 0 is nothing but 1. So 1 minus 1 will become 0. So this will become for the case k is not equal to 0. So in order to find the value for the x of k for k is equal to 0, we'll substitute k is equal to 0 in the equation 1 and we'll evaluate. So before that, what shall we do is, so this part of the equation is similar to the equation 1, but here the term is missing, is a term is missing here. So we'll multiply the a to this one, or else we can substitute this part of the equation. This part of the equation will go substitute for the in place of the equation 1, we are going to substitute in the equation 1 here. So if you substitute x of k, we got as a divided by omega to the power of k minus 1. So this is for the case k is not equal to 0. Now let us substitute k is equal to 0 in the equation 1. So this is the equation 1. This is the equation 1. So in the equation 1, we'll substitute k is equal to 0. So if you substitute k is equal to 0 in this equation, so what we'll be getting is omega to the power of 0 is nothing but 1. 1 multiplied by n will be the n will get here. So now we know the summation of n with finite sums will be equal to the n into n minus 1 divided by 2. So this is for the case k is equal to 0. So let us summarize the value for the x of k. We got the value for x of k for k is equal to 0 as well as k is not equal to the 0. So for k is equal to 0, we got a divided by a into n minus 1 divided by 2. This is for k is equal to 0. And for k is not equal to 0, a divided by omega to the power of k minus 1 we got here. So this is the DFT of the sequence. It is a into n. So this is we have converted we use the sum of finite terms formula and we are converted in the form suitable for solving the problem. So in the next section, we'll see the method to express the DFT as a linear transformation, so that we can use the DFT by find out the DFT by using the matrix method. We can do find.